section 5, we talked about our properties of logarithms so that we could solve some more complex logarithmic equations. So remember, when you're adding two logarithms, you combine it as multiplication. When subtracting, you combine as division, where the first logarithm is always the numerator. And then if there is an exponent inside a logarithm, you can bring it down in front of your logarithm. So our first set of examples, we are going to expand our logarithms. So we're going to write them as a sum, difference, or multiple of logarithms. For our first example, we have log 56. So there's more than one correct answer here since there's more than one way to multiply to 56. But I'm going to use the smallest numbers possible. So we're going to be doing, I can write it as log 8 plus log 7. It's not the only way that you can do it, but it is the one that comes to me quickest. And again, I don't have to write a base here because the base is 10. For our second example, we have log base 2 of 3x over y cubed. So this is going to be multiple steps. So my first step is to take my division and write it as subtraction. So it becomes log base 2 of 3x minus log base 2 of y cubed. Now in that first logarithm, I'm going to take my 3x, which is multiplication, and break it up as addition. So it becomes log base 2 of 3 plus log base 2 of x. And then for my second logarithm, I can bring that 3 down in front, and it becomes minus 3 log base 2 of y. Again, not as common for us to need to know how to break up a combined logarithm. What is going to be most important is rewriting logarithms as a single logarithm, because that's what we're going to need to solve logarithmic equations. So we have log base 4 of x plus log base 4 of 6. So that's addition, which means I can combine it as multiplication. So it becomes log base 4 of 6x. Our second example, log base 3 of 5 minus 3 log base 3 of 2. So before I combine this as division, I have a number in front of my logarithm that I have to rewrite as an exponent. So it becomes log base 3 of 5 minus log base 3 of 2 cubed. So now when I combine it as division, it becomes log base 3 of 5 over, and then I want to go ahead and evaluate 2 cubed, which is 8. And then our last example, log 7 plus 2 log x minus log 8. Again, the first thing I need to do is rewrite that number in front as an exponent. So it becomes log 7 plus log x squared minus log 8. And when you have more than 2 logarithms, you work your way left to right combining them. So first I'm going to combine log 7 plus log x squared as log 7x squared, and then my minus log 8. Now I combine using division, and it becomes log 7x squared over 8. So now finally, we are going to use our logarithmic properties to solve our logarithmic equations. So our first example, log x plus log 4 equals 2. So we combine it as multiplication, so it becomes log 4x equals 2. Now we are going to rewrite it in exponential form, which means I need to know the base of my logarithm. Anytime the base isn't written, it's base 10. So we're going to have 10 squared equals 4x. 10 squared is 100, so 100 equals 4x. Divide by 4, and x is 25. Our last example says log base 3 of x equals log base 3 of 2 plus 4. So my first step is actually going to get our logarithms on the same side. So we're going to subtract log base 3 of 2 from both sides. And again, we can't combine those as subtraction, so it's log base 3 of x minus log base 3 of 2 equals 4. Now I can combine subtraction as division, so it becomes log base 3 of x over 2 equals 4. And now I can convert it to exponential form. So my base 3 to the 4th equals x over 2. 3 to the 4th is 81. And then we will multiply both sides by 2, and we get x equals 162.